So this is the first day of my winter break for my students, and why not spend it recording some lessons, getting ready for semester 2 of PreCalc. So our first lesson, I don't have a header page here, but it's going to discuss a review of right triangle trig mostly. So this is a good review for any Algebra 2, PreCalc, College Algebra trig student just getting started in the land of trigonometry. So on the notes for my students, there's a beginning topic here where it says explain about degrees and radians. And we have to remember from our little spurt in trig that you can measure angles in radians or degrees. So they're both measurement units for angles. And if you have a complete circle that's 360 degrees, you knew that when you were like a little baby. And then when you took some Algebra 2 courses, you were taught that another unit of measure for that would be 2 pi radians. So because of that conversion, or that relationship between the two measurements, we came up with a simpler conversion factor that if you have a degree measurement and you want to convert it to radians, all you have to do is multiply it by pi over 180. That's the same ratio reduced by a factor of 2. And then if you have a radian measurement and you want to convert it to degrees, you would multiply that radian measure by 180 over pi. It's the same idea of dimensional analysis, and we're going to actually be doing a lot of dimensional analysis when we talk in the next section about linear velocity and angular velocity. And we're going to treat it like we're in a science class, basically. So first, to warm up here, we have some degree measurements. Let's convert these to radian measurements. I don't know why my mouse doesn't work when I do this. I'll use a real mouse. Or not. There we go. We're going to multiply 375 degrees, and then using that conversion from the other page, to go to radians, I'm going to multiply by pi over 180. And then, what I always have my kids do when they start off with this is rewrite it as generally an improper fraction, and that's okay. And then on your calculator, if you have the ability to use one right now, you need to reduce this fraction. So the easiest way to do that is to just type in the fraction and hit math enter. If you're doing this without a calculator, I apologize. You're going to have to start dividing them by common factors. But I already did this problem, and it turns out that that fraction reduces to 25 over 12. So this becomes 25 pi over 12 radians. And then similarly with a negative angle, it doesn't change the conversion factor. You're still going to multiply by pi over 180. And then you have currently negative 135 pi's over 180. Now the more trig work you do, the more you start recognizing things. But if you don't recognize this fraction off the top of your head, that's all right. We're going to get that nailed down when we do the unit circle. This reduces to negative 3 over 4 pi. Radians, of course. Should always label. I mean, whenever you see a pi in a conversion of angle, you probably assume it's radians, but, you know, better to be safe than sorry and all that. Alright, so now let's go the other direction. We're going to multiply a radian measure by 180 over pi as a conversion. And this is a little easier because you don't even have to worry about the pi's. They're going to cancel out. You end up with 180 divided by 3, better known as 60. Tablet's slow again today. Let's try. There we go, 60 degrees. Same idea with a negative radian measure. Multiply by 180 over pi. There we go. Pi's cancel. Negative 103 times 180 over 18, what's 10? So that's negative 1030 degrees. I think you can do it without a calculator if you have to. Totally fine. Alright, so some vocabulary. All my pre-calc kids either had Honors Algebra 2, where you had a great deal of trigonometry in your course, or if you came from regular Algebra 2, you were asked to take a trigonometry course in its entirety. So you guys probably are well aware of this material, but a coterminal angle means that you can have two angles that begin and end in the same spot. So you have the same terminal ray, and even regardless of how many rotations they go or what direction they travel, they have the same beginning and ending spot. So that's coterminal. So I usually just shorthand it as same terminal ray, assuming they started in the same spot, which generally they start in standard position of 0. degrees and radians, our unit of measure. We talked about the conversion between the two on the last couple slides. And then when it says the idea of all coterminal angles. So this is where it gets kind of confusing, because when you start measuring angles and rotations, like unless you restrict your rotations, you can rotate forever, and you can rotate forever in every direction, you know, positive and negative. So what we're going to do is we're going to have a little notation for coterminal angles of any angle. And if you're measuring in degrees, what we're going to say is that you can, I think your book says just to add 360 n or k or something, but I like the notation of using plus or minus because it just reminds me that I can go both directions. But come on, pen. 360, and then you can use any variable you want to represent k, which k is going to be any, in my example it's any whole number, but generally your book calls it any integer. So one group of 360s, two groups of 360s. Now because of your book not having the plus or minus in front, that's why they call them integers, because you could have -5 groups of 360, that would be going backwards. So anywho, let's talk about the same issue if we're measuring in radians. Well, coterminal for radians would be adding and subtracting full rotations in radians, which we know are 2 pi's. So, oh my gosh, it's not my day. All right, 2 pi k. And again, where k is any integer is how your book describes it, because they'll just have 2 pi k instead of the plus or minus. We're going to use that notation quite a bit when it comes to solving trigonometric equations later, so look forward to that. This is, I hate these questions. I hate grading them, is what I hate. So find a positive and negative coterminal angle. Well, the problem here is there's a lot, and if I just give you the freedom to choose anything you want, then there's a whole bunch of answers, and there's always some kid out there who's like, oh, I'm going to add 47 rotations. All right, fine. So I'm lazy, so I'm just going to add 1 rotation, and I'm going to subtract 1 rotation, and if that doesn't get me a positive and negative, then I'll keep going. But clearly, if you add 1 rotation to 36 degrees, you're going to have 396 degrees. That's a positive coterminal angle. And if we subtract a rotation, exactly in that order, has to be original minus the rotation, you get -324, which is clearly a negative angle. So positive angle, negative angle, those would be the easiest answers to come up with for my teacher. But there are a lot of answers. So same thing here on -405. The issue you're going to have with -405 is when you add a rotation, like that's not going to be positive yet. So like you're going to have to add another rotation. You're going to have to add 720 to it. So I'm going to show you here how you can kind of shorthand it. So -405, and then you can say plus or minus 360. Okay. That's a way to include all coterminal angles, and it would get literally every positive and negative one included in the answer. Okay. Same thing with radians. So here, if I am going to come up with 1 positive coterminal angle, I would be adding a rotation of 2 pi. So you do have to think about fractions here. If you don't have a calculator, it's not the end of the world. This becomes 6/3 pi, right? So that's 11 pi over 3. That would be 1 positive coterminal angle. And now if we're going to take away a rotation in hopes that we're going to become negative, instead of subtracting 2 pi, I'll cut out the middleman and just call that -6 pi over 3. -5 pi over 3 minus, 5 pi over 3 minus 6 pi over 3 is -1 pi over 3. So there's a negative coterminal angle. So on this next one, let's cheat and let's just write that weird notation, plus or minus 2 pi k. And that would be including all the coterminal angles. Now, the directions did say, like, find exactly 1. So if that was your test question, I would expect you to find, like, 1 example. I'm going to skip this little YouTube video, but, you know, if you want to go to that address, it gives a nice little description about right triangle trigonometry. So SOH CAH TOA is, I guess it's a mnemonic device for sine, cosine, and tangent ratios of right triangle applications. And yes, you have to have that memorized. You probably had to have it memorized the last 2 years of math, so what's new? SO stands for the sine, that's the abbreviation for the function sine. Sine of some angle x is representative of the ratio of the opposite leg over the hypotenuse. And then cosine, that's the abbreviation for cosine of x, is the adjacent leg over the hypotenuse. And then tangent of angle x is represented by the ratio of opposite leg over adjacent leg. So here, find the measure of each angle indicated. So here what we're going to do is we're going to set up our right triangle trig ratio, and then we're going to use an inverse function on our calculator to come up with the angle, and we're going to be rounding to the nearest tenth of a degree. So first thing I want you to do is make sure that your calculator is in degree mode. And then I know a lot of you tried to skip these steps when you're in Geo and Algebra 2 because you're like, oh, these are easy. And I'll just type it in my calculator because I know it's going to be cosine. Even at PreCalc, I hesitate to jump the gun like that, all right? So this is our angle of reference. This is the angle theta. So according to this angle, I have the adjacent and the hypotenuse, which is the cosine function. So we're going to set up the cosine of theta is adjacent over hypotenuse. Now, if you think about just regular algebra, if I'm trying to solve for this angle theta, I have to undo the cosine function. So you can't divide by a function, you have to undo it with his inverse. So the inverse of a cosine function is the arc cosine function, which you guys call like second cosine when you're in geometry. So you're going to second cosine that, and you're going to second cosine that whole ratio there. So when you do that on your calculator, and I'm not going to pull up my calculator because I know you guys are well aware of how to do this, you find out that theta is 56.3 degrees when you round. Again, if you don't get that answer, you probably have your calculator in the wrong mode, so check your mode. Alright, here's my angle of reference over here, theta, which is angle A. So angle A has an adjacent and an opposite side being associated with it right now. Those are the sides that are given to me. So that means I'm going to set up tangent. So tangent of angle theta is opposite over adjacent. So to undo the tangent, you have to second tangent it. Arctan. So applying the inverse tangent technically to both sides of the equation is what cancels the tangent out. But inverse tangent of 9 over 3.7 through the art of technology and history, because I already solved this, is 22.3 degrees. I know, it's like the third year you've had to do these problems, so I'm sure you're very good at them by now. This time, I'm going to give you an angle and one side, and I want you to find another of the missing sides of the triangle. Now, probably in Algebra 2 and Geometry, your teacher wanted you to find like all the missing parts of the triangle, which really isn't that difficult. Once you do this trigonometry step, it would have been like some basic geo, like Pythagorean theorem work, triangles add up to 180, so the, theorem that you would use there. So here we have, this is our angle of reference, this is opposite of that angle, and this is the hypotenuse to this triangle, so we are setting up sine. So it's the sine of 64 degrees equals opposite over hypotenuse, so 25.6 over x. And then I know my kids always tell me, like, oh, my geometry teacher gave me like a little cheat sheet of what I should type in my calculator. Well, you're not going to get one of those in PreCalc, so make sure you understand that this is just a cross product. It's a proportion. So if you were to multiply x times sine of 64, and then, that's not sine. Oh my gosh. Maybe I shouldn't be doing work over winter break. Maybe this is a sign that I shouldn't do any work. Alright, x times sine of 64 equals 25.6, and then in order to solve for x, you would be dividing by the sine of 64. I know after you solved like 20 of these in a row for homework, you started seeing a relationship like, oh, if x was in the denominator, then I take the number divided by the trig number. Whatever makes you happy, guys. Alright, so we're rounding to the nearest tenth again, and I already solved this. I'm just going to steal my answer. It's 28.5. And they didn't label the legs earlier in the problem, so we won't label ours either. Alright, here's my angle. It's 40 degrees right here. And I have the opposite leg, and the adjacent leg is the one that I'm trying to find. So with those clues, I would be setting up tangent of 40 equals opposite leg over adjacent leg. So again, if you think about cross-multiplying this proportion, you're going to end up with a division of 3.6 divided by the tangent of 40. Alright, so I already solved this, and I think I got 4.3, which makes sense for my triangle. That's my favorite part of these questions, is when children will solve them. My lovely Algebra 2 children. And they'll get a really strange answer and then not think anything about that. Like for this triangle, they'll get a leg of 487 or, you know, something crazy. Like, no, it doesn't make any sense, guys. Alright, so keep in mind. Same stuff here, guys. We have the angle given to us here. This is the adjacent leg, and then this is the hypotenuse. So with those clues, we'd be setting up cosine of 60 equals adjacent over hypotenuse. Now this time, when you solve this cross product, it just is one step of a multiplication, right? You're just going to do cosine 60 times 17. Please be careful that you stop the cosine function with a parenthesis before you multiply by 17. Or better yet, just multiply 17 times cosine 60 and then you don't have to worry about it. Order doesn't necessarily matter, but the way you type it totally does. So I already typed this on my calculator and I got 8.5. The reason that one comes out so nice is once I remind you about the unit circle in a couple days, you're going to remember that cosine of 60 is something pretty. Alright, number 17, we have the opposite and the hypotenuse. So we're setting up sine again. Sine of 47 equals opposite over hypotenuse. So this is one of those cross products where we're going to end up doing 19 divided by the sine of 47. So when you type that in, 19 divided by the sine of 47, whoops, you get 26.0 when you round to the nearest tenth. Alright, so we have to talk about the reciprocal functions, and we didn't do a great deal of this in Honors Algebra 2, but the regular Algebra 2 kids who took the Trig course, you probably did a lot of work with the reciprocal functions. Now, do not confuse reciprocal functions with our inverse functions. They are not the same thing. We'll talk about the inverse functions later on. We've done a little bit of work today with finding the angles, but cosecant is the reciprocal of sine, and then secant is the reciprocal of cosine, and then cotangent is the reciprocal of tangent. So all of those little baby formulas, opposite, adjacent, hypotenuse formulas, are just you're gonna take the reciprocal of those fractions for their reciprocal functions. Yeah, you have to have it memorized. Like everything else in my class. I know, you're sick of it. Alright, so cotangent of angle theta. Let's see. Oh, you know what? Let me back up a minute. I don't know if I read the instructions. Oh yeah, I did. Alright, so this is a little different. It doesn't say find the measure of the angle. It just says find the value of the trig function. So all they really want is the ratio. We don't even have to do calculator work here, guys. Oh, we do have to do a little bit of calculator work because I just realized I wanted cotangent. Now, tangent is the opposite over adjacent, so cotangent is adjacent over opposite. Problem, guys. I have the opposite. I don't have the adjacent side. That's okay. Geometry's come to the rescue here. We have Pythagorean theorem. So we're going to set up 6 squared. Actually, I don't even know if we have to set up anything, because this is a special triangle. This is one of our Pythagorean triples. If you recognize it, this is a 3, 4, 5 that's been doubled. 3, 4, and 5 being doubled. So if this is a 4 doubled, this must be an 8. But if you didn't recognize that, that's okay. You still would do Pythagorean theorem. You'd have to take 100 minus 36, which is 64, and then square root it. And guess what? You still would have got the 8. Pythagorean triples are neat little tricks that like my math team kids use a lot. And SAT and ACT testers like to use. So anyways, we're still not done. I need the ratio for cotangent, and we said it was adjacent over opposite. So I would set up 8 over 6, and then I go, oh, that's not a good answer. I can reduce that ratio to 4 over 3. Cosecant is the reciprocal for sine. So if sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. So, bit of a problem. We don't have the other side. So we're going to have to set up Pythagorean theorem, or we'd have to recognize that this too is a Pythagorean triple. It's one of my favorite ones. I have a really cool poster in my room regarding a football Pythagorean theorem pun. Go check it out if you're in there, okay? This Pythagorean triple is 7, 24, 25, but you would get that 7 through solving this Pythagorean theorem equation. So now I know that the hypotenuse is 25, and the opposite leg to the angle is 7, so the cosecant ratio is 25 over 7. Alright, tangent. Okay, this is not a pretty Pythagorean triple. but it is definitely going to involve Pythagorean theorem because I'm going to need to figure out this side before I can set up any tangent. So setting up Pythagorean theorem, x squared plus 18 squared equals, now this is where it gets kind of funky. If you're squaring this mixed radical here, you're going to square the 9 and you're going to square the square root and multiply those answers together. So I'm just going to leave this as 18 squared for a minute because I don't have the calculator on me right now. But 9 squared is 81, and then square root of 5 squared is just going to be a 5. So, did I already solve this? You know what? Oh, it's so irritating. I didn't show my work. So, 405? I'm going to go with that. So after I subtract 18 squared here, whatever that is, and then I square root that number, you know, this thing, square rooted. Spoiler alert, I got 9. Okay? Which is great, but that's not my answer. Tangent is going to be opposite over adjacent. So 18 over 9, better known as 2. You do want to reduce those trig ratios, just like everything else with math. So this is actually a really easy question. Find the cosine if the secant is 13 over 5. Well, aren't these just reciprocals of each other? So the secant's 13 over 5, so the cosine would be 5 over 13. Boom. I've seen a lot of those type questions on the ACT test, and the ones coming up here where you have to do a little bit of work. I'm not certain that the SAT test has this much trig on it. It does have a little bit of trig, but nothing like this. Like the ACT used to have a ton. Well, I take that back. It only had 4 questions. It just felt like a ton on the ACT because like you could bank on them having those 4 questions. But, you know, 4 out of 60 questions for everything that is in math, that's kind of a lot. So here, I like to draw myself a really boring right triangle. And then I'm a creature of habit, so I always put my angle of reference like down in the corner. And then I fill out the clues they gave me. So the tangent ratio is 8 over 15, which means my opposite leg is 8. And my adjacent leg is 15. So they want cosecant, which is the reciprocal of sine, so it's hypotenuse over opposite. Well, I have the opposite, but I need to do a little work and find the hypotenuse here. So this too is a Pythagorean triple, I think. 8, 15, 70, I'm pretty sure it is, but you know, just in case, let's check it out. 8 squared plus 15 squared equals x squared. So what is that? 64 plus 225 equals x squared. Yeah, this is 289, and then when you square root that, you get 17. Yep. So that is a Pythagorean triple. Apparently, it's the one that I always forget. So, if you already knew that, like, you would have been done a lot quicker than me. Yay for you. So hypotenuse over opposite would be 17 over 8. There we go. All right, another fun one. I don't see a direct relationship between secant and cotangent. So just to kind of visualize what's going on, I'm going to have to draw myself a little picture. Cotangent is the reciprocal of tangent, so it's adjacent over opposite. So adjacent is square root of 11. Opposite is 5, and this is not like a typical Pythagorean triple because it's not even an integer. So we're going to set up Pythagorean theorem where you take the square root of 11 squared plus 5 squared equals the hypotenuse squared. So that's 11 plus 25. Oh, that's nice. Comes out to 6, huh? So hypotenuse is 6, and they want to know the secant ratio. Well, secant is a reciprocal of cosine, so that would be hypotenuse over adjacent. So hypotenuse, oh no, triple whammy. Technically, this is not an acceptable answer in the old school mathematical community. Now, I've had talks with our calculus teacher who say they actually don't care if you leave your answer like this anymore in like big kid math, but I don't know. You might have like a stick in the mud fuddy-duddy professor. So you want to make sure that you know how to rationalize the denominator. So let's square root each side of the fraction by a square root of 11, multiply each side of the fraction by square root of 11. This is called rationalizing the denominator. This blue thing I just wrote down is equivalent to a 1. That's why it's okay to do. And then this becomes 6 times the square root of 11 over, this is the equivalent of squaring the square root of 11, so it's just over 11. That is the rationalized, reduced version of the ratio. Say that 3 times fast. Oh, there's all the answers. Lovely, right? I think that's the beginning of our review of right triangle trig. So we have another lesson coming up shortly that goes into some more vocabulary and then also brings back our angular and linear velocity formulas. So it's going to be a good time. Look for that next lesson.